So to begin this activity, start by opening a new sketch window if you don't have one already, by clicking File, New Sketch. Select from the Edit menu the Preferences option and make sure that the precision is set to hundredths. Now from the Graph menu, we'll select the Show Grid option as well as the Snap Points option. This way, any points or lines we attempt to place on the grid will always go to an integer numbered point. So now we'll select the Construct Line tool, go to point 2, 3, so 2, 3, and click. Next we'll move to the point 3, 6, and click again. So now a line appears through the 2 points. Let's repeat steps 6 and 7 using the following pairs. So we construct a line from 3, 6, so we click, to 6, 7, where we click. From 6, 7, we'll click again, and go down to 5, 4, where we click. Finally, we'll click on 5, 4, and back to our starting point at 2, 3, and click. So now we've created a rhombus. Let's use the Line Selection tool, and we'll select the first line segment only. Now from the Measure menu, we'll hit Slope. So we see that the slope of this line is 3.04. When you're using Geometer Sketchpad, sometimes rounding errors occur. You can see from the grid the slope is obviously a rise of 3 and a run of 1. This difference of 0.04 is simply due to rounding errors when the computer calculates, and it should be taken to be a slope of 3. So now we're going to repeat this procedure for each line segment. So we'll take this line segment and calculate the slope. Must make sure that the slope is deselected. Now we can click Slope, and we get a slope of 0.33 for BC. We'll deselect and click on the third line segment, Measure Slope. We see that it's 3.04, just like AB. Deselect, select AD, Measure Slope, and we get a slope of 0.33, the same as side BC. So now let's highlight the first line segment again. So we'll deselect this slope, select the first line segment. Now we're going to measure its length. So we see that its length is 3.16. So now let's measure each line segment. So we can see that all 4 line segments have the same length, 3.16 centimeters. So since they have the same length, opposite sides are parallel, but adjacent sides are not 90 degrees, this shape is a rhombus. So now let's use the Line tool to construct diagonals. So we'll click point B and point D, and we'll click point A to point C. We've now constructed diagonals for this rhombus, so we'll change to the Select tool, make sure one of the diagonals is highlighted, and we'll measure its slope. So we'd see that the slope of diagonal AC is 1. Click diagonal BD, measure, make sure slope is deselected, measure, slope, its slope is -1. Now if we go to the Measure Calculate, we'll type in -1 divided by, and we'll click on the slope of one of the diagonals, press OK, and we'll see that the negative reciprocal of AC is equal to the slope of BD. So they are perpendicular bisectors of one another. We already know that the diagonals of rhombuses bisect each other. Now we know that they are perpendicular bisectors. So now let's use the Select tool. We'll deselect this calculation, And we're going to drag the points of this rhombus to change it into a square. You'll notice that again, our slopes are negative reciprocals of one another. So the diagonals of a square are also perpendicular bisectors of each other. Finally, let's check the length of these diagonals. So we'll measure the length of one. We must make sure that only the line segment is selected. And now we'll measure the length of the second diagonal, and we see that they're the same. So now, not only are the diagonals of a square perpendicular bisectors of each other, like they are in a rhombus, but in the special case of a square, the diagonals are an equal length.